A rusted nail holds a secret about time itself, and it's been playing out on every fence post you've ever seen. That secret isn't hidden, it's visible. Every flake of rust you've ever scraped off a gate, every orange-brown stain bleeding down a roof, that's time made physical. That's chemistry and physics having a conversation in real time right in front of us. Most of us learned rust in school as a simple equation. Iron plus oxygen makes iron oxide. We moved on, but that equation is incomplete. It's missing the real story, why iron wants to rust, what's driving it, and what that tells us about entropy, about the universe's relentless march toward disorder. Let's go back. Picture an iron atom sitting alone in air. It's stable, yes, but it's not at peace. Iron has 26 electrons orbiting its nucleus. Some of those electrons want to move. They want to bond with oxygen atoms. And when they do, something extraordinary happens. Energy is released. Not a lot, but enough. Enough that the universe prefers this new state, this iron oxide, to the old one. Rust is the universe's way of saying this is better, this is lower energy, this is what wants to happen. But here's what most people miss. Rust needs water. Not just water. Water with dissolved oxygen, that's the real catalyst. Pure oxygen alone rusts iron slowly, almost reluctantly. But water is the accelerant. Why? Because water lets the electrons move more freely. It becomes a highway. Oxygen ions travel through it. Iron ions travel through it. They meet, they bond, and rust spreads fast. This is why ships sink, why bridges need maintenance, why your car's underbody corrodes faster in winter. Salt and moisture, the perfect storm. Water plus oxygen plus time equals decay. It's not a flaw in the metal, it's a feature of physics. Now here's where it gets interesting. Rust isn't just one compound. There are many kinds. Iron oxide, iron hydroxide, iron oxyhydroxide. Each one forms under different conditions. Each one is a fingerprint of the environment where the metal lived. Archaeologists know this. They read rust like a book. A Roman nail pulled from the ground tells them about the soil's acidity, about humidity, about how long it's been buried. Rust is a timer, a record keeper. But rust also teaches us something deeper. It's a visible reminder that everything wants to fall apart. Not in a depressing way, in a physics way. The second law of thermodynamics says disorder always increases. Entropy wins, always. Iron used to be in a star, billions of years ago. That star died. Its core was fused into iron, an ordered, stable element. We mined it. We shaped it into nails and bridges and cars. And the moment we exposed it to air, entropy started working, pulling it back toward disorder. This is why we paint, why we galvanize, why we coat steel with zinc. We're not fighting rust. We're fighting time itself, and we can slow it down, but we can't stop it. Eventually, the atoms will find their way back. That's not failure, that's physics. Every scratch on a painted surface is a countdown timer. Moisture seeps in. Oxygen reaches the metal. The electrons start their ancient dance, and rust begins again. Some metals don't rust the way iron does. Aluminum oxidizes, but the oxide seals the surface it protects. Copper turns green, but that patina is stable, almost permanent. Each metal has its own entropy story, its own timeline. The Statue of Liberty's copper skin has been oxidizing for over a century. That green color isn't damage. It's a chemical equilibrium. The copper has found a stable state with the air around it. It's beautiful because it's stable, because time has finished its work. But iron can't rest like that. It keeps corroding, layer after layer, flake after flake. Given enough time, a nail becomes dust. The atoms scatter, and somewhere down the line they might be iron again, in another nail, in another tool, in another story. So when you see rust, you're not looking at failure, you're looking at time. You're watching the second law of thermodynamics play out in real time at human scale on something you can touch. Rust is entropy made visible, and that's extraordinary. Subscribe. Each week we reveal the hidden physics in the objects you live with every day.